Okay, on this page of notes, what we're comparing is when I can repeat or not repeat, when I have replacement or I don't have replacement. That's what we're comparing in this set of notes. So when I can pick the same thing twice, or when I cannot pick the same thing twice. All right, and so I have to be very careful in this case. So suppose I've got that bag of M&Ms. It's the same bag of M&Ms I had earlier. 13 blue, 7 brown, 12 green, 9 orange, 7 red, 8 yellow, and so there were a total of 56 M&Ms in the bag. Right? And that's true for both the problems we're going to do. So the same total. And so what we're going to do is we're drawing 2 M&Ms. I pick one M&M from the bag, look at its color, and then put it back in the bag. And then select a second M&M. So there's the first pick and its probability, and the second pick and its probability. So you've got your first pick and your second pick. When you do this, you're going to find both of those probabilities and multiply. What you're going to make a note of is, since I put it back in the bag, is the totals are the same in both selections. Because you could technically pick the same M&M twice. Right, I pull out a blue M&M, I'm putting it back, I could pick it out twice, right? I could pull out the same blue M&M twice. And so the totals are the same. You still have 56 M&Ms in both draws. You have the exact same color of M&Ms in both draws. And so, as it turns out, it's the same probability whether it's the first draw or the second. I just do it twice. And so when I find the probability, I have to multiply. So I've got the first pick and the second pick. So the probability of the first pick, well, the first pick I am going to pick, so both are green, all right? So we're looking at probability that I get a green on the first and a green on the second. So probability of the green on the first, well, out of 56, there are how many greens? 12. And, so we multiply, the word and means we multiply. I'm doing this and this. On the second pick, I'm still going to pick a green marble, and since I replaced it, I could technically, not marble, M&M, I'm going to pick a green M&M. I could technically pick the same green M&M twice. So I've got 12 greens still on my second pick, and I've got 56 total on my second pick. And so it's just basically that same probability twice. 12 over 56 for the first and 12 over 56 for the second. You multiply that out and it comes out to be, I'm just going to write the decimal, 0.046. About a 4% chance of getting green on the first. Put the green back, green on the second. Alright, well, the same thing for the second one. So probability that they're red. Now the difference here is I'm looking for red. So I get a red on the first and a red on the second. We replace it. I took the red out, put it back in, so I could pick the same red one twice. So I have the same number in both picks. Alright, so red. There are 7 reds, so I had 7 reds out of 56 for my first pick. And I still have 7 reds out of 56 for my second pick. Alright, so the probability didn't change because I had the exact same number of reds and the exact same number of marbles in the first pick and the second pick. Alright, so those are the two probabilities, and then you multiply that out, and you have fewer reds, so it should make sense that it's a smaller probability. Alright, it comes out to 0.0156, which is smaller than the greens. Again, I only had 7 reds versus 12 greens, so it should make sense, so it comes out smaller. Alright, what we're going to do is we're going to compare this to, so that was I replaced it, which means I could pick it again. What happens if I don't replace it, or what do I do if I don't replace it? All right, so the same bag, so I still have the same total. 56 to start. But this time, you pull out the color and you eat it. All right, you're not going to put it back. And so, what that means since you eat the first pick, you cannot pick that M&M again. This is a non-repeat. Case. So you have one fewer of that color. So you need to subtract that from the second pick. Alright, the second chance is different because I have one fewer of my M&Ms total. Alright, so the first example. So find the probability that both M&Ms are green. So again, I'm doing the same one, but it does change things. So I get green on my first and green on the second. But this time, I don't replace the first green. So the first probability is the same. The first pick, I still have 12 greens out of 56. So 12 out of 56. And I still multiply, because when we use the word and, we multiply. In the second pick, though, I've got one fewer green and one fewer total M&Ms, right? I've eaten one green M&M, which means there are only 11 greens left. I've eaten one M&M, so that means there were only 55 left in the bag. And so the second probability, you subtract one from both. I only have 11 greens and 55 total. Right, so it does change the probability. Probability should be different because I've got a different probability for that second outcome. And it does. 0.0428. Not a whole lot. It doesn't change a whole lot, but it does change. It goes down. It was 0.046. Now it's 0.042. Right, so it's a different. So 46% chance versus a 42% chance. Similar thing will happen with the red. So again, I pick the first red and the second red. So the first red's the same. I still have, again, we're assuming we start with the same bag in this probability. I haven't eaten anything yet. So I've got 7 out of 56 for the first one. And for the second red, I've eaten a red marble. I keep saying marbles. Eaten a red M&M, which means there is only 6 left. And since I've eaten one M&M, there's only 55 total. So this one is 6 out of 55. And then you multiply. And again, it should come out less than, not a whole lot, but it does come out less. 0.0136. And it does. Right? The probability is less than the previous case. Right? The previous case was 15.6%, or not 15, 1.56%. This one was 1.36. Alright, so it affects the second probability changed without replacement. Alright, so if we don't replace something, it affects the second probability. Alright, so I'm going to do another example with cards. Alright, so again, we're going to go back to our deck of cards. So I've got my I'm going to draw 2 cards now. And without replacement. Without replacement means once I pull the card out, it sits over to the side and I don't put it back in the deck. Right? So I picked it, and you don't pick it again. So like if you're dealing, if you're playing 21 and you're dealing out 2 cards. Right? The first card, and then when the second card, there's one fewer card left in the deck. Alright? So the second pick has 1 fewer cards. Right? Whatever the first pick was. Alright, find the probability both cards are red. So we get our first is red and our second is red, but we don't replace it. So remember, half of the deck is red, so 26 of the cards are red. So the first pick, there were 26 red cards out of 52. However, I've taken a red card out, whatever it is. There's one of my red cards, and I've placed it to the side. I don't put it back in my deck. So now I pick again, but this time I have one fewer red card and one fewer total card. So instead of 26 red, I only have 25, and instead of 52 cards, I only have 51. So the second pick is 25 reds left out of the 51 cards left. And then you multiply that out, and again, I'm just going to write that as the decimal, 0.245. Alright, both cards are clubs. Remember, clubs, there are 13 total when you start. Alright, one suit is 13 cards. You can go look at it and count. One suit. Clubs count up to 13. So we get the first pick is a club, and the second pick is a club. But remember, once we pick a club, we don't put it back. Alright, so the first pick, no, there are 13 clubs out of 52. However, when we go to pick the second one, we've already picked a club, so there are only 12 left. And since we already picked a card, there's only 51 cards left when I pick again. So there's only 12 possible clubs out of 51 for my second pick. Right? I have to subtract. And that comes out to, when I do the 0.0577, the decimal. Alright, so again, with replacement, without replacement, changes the second probability. Alright, we'll stop there. I'll do the last thing in my last video.